Sorry about getting cut off so quickly on that last one. There was some technical difficulties there. But where we're picking up is finding a residual plot on your calculator. Okay? So we're going to follow the steps that we've already done. Most of these we've already done. So we've entered our data. We're still using our McDonald's beef one. Okay? We're going to do this whole scatter plot thing, find the line of best fit. We're going to store it just like we did before. And then we have a couple extra steps. Okay? Because you got to actually calculate your residuals. So let's make sure that we're still good to go. So if I go to Stat, Edit, my data is still in there. My stat plot, somehow got turned off, so let me turn that back on. And we're going to be making a scatter plot with our list 1 and our list 3. The way that I made that say 3 is I hit second and then the number 3 button, because there's a little L3 above that. And now there's nothing in list 3 right now, but there's going to be once I put my residuals in there. So I'm going to exit out of here. And my Y, mine is empty, so I need to put my equation back in there. So how do I do that? Well, I go to Stat, I go to Calc, go down to option number 8, list 1, list 2. I want to store it in Y1, so I go to vars, function, Y1, calculate. All right, so now Y equals, all right, my line is there. Cool. So what I need to do is I need to calculate the residuals. And I'm going to put that in list 3. So what is a residual? It's the actual Y value minus your predicted Y value. Now, I'm going to put my arrow up so it's highlighted on list 3. Where are my actual Y values located right now? They're located in list 2. So I'm going to type second 2. And it's the difference, so I'm going to subtract the predicted values. Now, how do you get a predicted value? Well, you have to plug in your X value to your prediction line, to your least squares regression line. So how do I do that? Well, I need to get my line. So I'm going to go to vars, scroll to yvars, function, y1, and then into that line of best fit equation, my least squares regression line, I'm going to substitute in my X values, which are in list 1. Okay? Notice how all this is happening? I write this down here, but this L3 is highlighted. So then when I go and I press enter, all of my residuals appear. Okay? So now when I go to make my scatter plot, it's going to graph my list 1 compared to my list 3. So if I go to zoom, option number 9. Oh, there's my line of best fit up there. I don't really care about that right now. But here is my residual plot. It's okay. It's not the best residual plot. I have, 1, 2, 3, 4, 5 below, 1, 2, 3, 4 above. There doesn't really seem to be a pattern. Maybe it gets a little bit more spread out as my X values get bigger, but for the most part, it's a pretty decent residual plot. Okay? Now, what else can we do with residuals? I'm glad you asked. In addition to creating a residual plot, we can calculate the standard deviation of the residuals. Now, the mean residuals for a least squares regression line is always 0, so that doesn't help us. So standard deviation is going to be really important. Here's our formula for standard deviation of residuals. Okay? Another option is to just use the one variable statistics on your calculator after you've made a residual plot. Now, the only thing you need to be careful of, the true formula divides by n minus 2. This formula divides by n minus 1, so it might be slightly off. Okay? Now, how would you interpret it? Here's where it gets a little tricky. S, my standard deviation, represents the typical or average error for a residual. Okay? So remember, positive residuals, we've underpredicted. Negative residuals, we've overpredicted, because it's the actual value minus the predicted value. Okay? So let's go ahead, still using our McDonald's beef fat and carb example, let's go ahead and calculate and interpret the standard deviation of the residuals for that. So according to our formula, to find our standard deviation, S, of our residuals, that's an S, not a 5, we have to take the square root of the sum, that's a terrible sigma, there you go, the sum of my residuals squared, divide that by n minus 2, where n is the number of pairs. Okay, so how do I figure that out? Well, I would square all my residuals and then add them up. My residuals are already in my list. They're still in list 3, right? They're right there. So if I were to go to Stat and over to Calc and do one variable statistics for list 3, it's going to give me the sum of the squared values. So 341.05, etc., etc. That's my numerator. Right there. Nice and easy. So I've got the square root of 341.051858. Might as well write them all. Be exact. And I'm going to divide by the number of pairs minus 2. So there's 9 numbers minus 2. So plug that into my calculator. I get about 6.98. Okay? Now, if I had just used what the calculator told me, I would have gotten 6.53. So pretty close, 6.98, 6.53. It's not a huge difference which one you use. But this one's not too hard to calculate by hand. So now here comes the interpretation. This is the big part. How would I interpret this? Well, I can say that predictions for McDonald's beef sandwich fat, always include your context, is going to be off by an average of 6.98 grams of fat. Okay. So, good prediction of standard deviation for residuals. Okay? So a quick recap here between residual plot and standard deviation of residuals. Residual plot is a graphing tool. Tells us how well a regression line fits the data. Standard deviation gives us a numerical estimate of the average size of our prediction errors. Now, there is another numerical quantity that tells us how well the least squares line predicts the values of the response variable. And this is R squared. This is called the coefficient of determination. So just R is your correlation coefficient. R squared is your coefficient of determination. Now, it literally is just R squared, so the correlation squared. But it's more important, right? It is the fraction of the variation in our y that's accounted for by the line. Now, there's a big fancy formula for how you were to do it by hand. I'll never make you do it by hand. Okay? What would it look like if you were trying to fill it out by hand? Something like this. Kind of ugly, so I wouldn't make you do that. If you know R, you just square it to get R squared. It's also in your calculator output when you calculate R. Now, how do you interpret? A couple different ways. You can either say whatever the percent is, so we always convert it to a percent. So whatever the percent of the variation in your response variable, so insert the context there, it can be accounted for or explained by the regression line, right? It can be explained by that linear relationship with x. Another way, if you want to word it differently, the least squares regression line accounts for whatever percent of the variation in your response variable. Again, insert the context. So let's actually look at an example. If my r squared was 0.875, now r squared obviously will always be positive because when you square a number, it'll always be positive. If you want to interpret it where x represented the hours studied and y was your SAT score. All right? Or if your r squared was this, x was hours slept, and y was your alertness score. How could you interpret? Whatever percent, so 87.5% of the variation in your SAT score can be explained by the linear relationship with the number of hours studied. Or 52.3% of the variation in your alertness score, which was your y, is explained by the linear relationship with the number of hours slept. Okay? So, that's how we interpret r squared. Last thing we're going to do in this video is look at some computer output. Right? From computer output, we should be able to determine the equation of the least squares regression line, the standard deviation of the residuals, as well as the coefficient of determination, which then should lead us to finding r itself, because you would just square root it. Now, you will have to use your brain and think, because r squared is always positive. So if you have a negative slope, you should then have a negative r. So from this output right here, this is how it's always going to be laid out. So you kind of just have to memorize. Intercept is going to come first under this little coefficient one. The slope comes immediately underneath of that. All right? We're going to ignore the rest of this junk for now. Under the standard error coefficient, the t, the p, that'll all make sense later in different chapters. For now, all we care about these two numbers. And these two down here, these ones are a little easier to identify. S is my standard deviation. R squared should be obvious what that is. Okay? So if you wanted to write your equation, right, y hat equals, and again, this is in the wrong order, but you get the idea. Defining your variables, whatever they may be. All right, let's look at two examples together. So determine the equation of the least squares regression line. All right, what comes where? Well, the number on top is always my y-intercept. Number underneath that is always my slope. Down here we have our standard deviation of our residuals. Over here we have our r squared. There is this thing called r squared adjusted. Not something we worry about in this class. So here is our equation. Okay. So let's look at another example. In this particular scenario, scatter plots based on quiz averages and final scores. So what can we identify? This number down here is the slope. Above that is our y-intercept. Down here we have our standard deviation of our residuals. Next to that we have r squared. Okay? Last example I want you to do, based on this scenario here, read it over, and from the computer output, let's see if we can identify our least squares regression line. Can you identify our least squares regression line from this data? Okay? All right.